We've now seen how to graphically represent preferences using indifference curves and how to numerically represent them using utility functions. Now, an indifference curve is really the same thing as a level set of a utility function. So fix some level of utility u bar. And then the indifference curve is just the set of all the different points or bundles that have the same value. So that satisfy the equation u of q1, q2 equals u bar. So think of, for example, plotting a utility function in 3 dimensions. So you put pizza on this axis, beer on this axis, and you put utility here. So you've got some surface, some utility surface. How would we get indifference curves from this thing? Well, what we do is we put a plane at the utility level u bar equals 2. So we cut this cube with this plane at the utility level of 2. And we see where this utility plane or utility surface cuts the plane. And it's along this curve here. And we do that at all different values of u bar. And we get all these different points of intersection between these horizontal planes and the utility surface. Now these are very similar to contour lines on a map. So here we've got a 3-dimensional surface. Now think of a contour map where you had hills and various terrain. So let's look at a contour map of Ottawa. So this is Ottawa. Now you can see that different elevations are represented with these lines. So all these lines represent points that are at the same height, the same elevation. So for example, here you've got these points that are at 60 meters, and so forth. So it's a little nicer to see if you go out to Gatineau, where you've got the hills. You see here that the different hills are marked with different curves. So if the height of the hill were your utility, or the higher you were, the happier you were, then these would be indifference curves for you. So doing the same thing, we've got these various curves. Let's say we shone a light from above, we would get this projection onto the plane where we have just beer and pizza. And those are our indifference curves. This collection of these curves gives us our preference map. So that as you go in this direction, you're made better off. As you get more and more beer and pizza, you're happier. So that gives us our collection of indifference curves. Let's look at an example. So think of the utility function that we had seen earlier, where the utility from the bundle q1, q2 is just the square root of q1 times q2. And let's say we want to find the indifference curve through all the bundles that give us utility 4. Well, of course, if you look at the bundle 4, 4, the square root of 4 times 4 is 4. So we know that the bundle 4, 4 is on that indifference curve. So is the bundle 2, 8. 4 times 4 is 16. So any pair of numbers that multiply to 16 would give us the same utility. So bundle 2, 8, or 8, 2, or 1, 16, 16, 1, they all give us the same utility of 4. So these are all going to be on the same indifference curve. So we've got this indifference curve that passes through the bundle 4, 4. We could do the same thing for the utility level 12, for 15, and so forth, or any utility level you like. Now remember, the indifference curve that passes through any bundle, like A, it divides the space into 3 parts. This is as we've seen earlier. There's the stuff that's better than A, or gives higher utility than A. The part that's worse than A, or gives lower utility than A. And the stuff that you're indifferent. So similar to the map that I showed you, those lines describe the points that are higher than the line through a point divides a space into the points that are higher than it, the points that are lower than it, and the points that have the same height. Similarly here, we've got the indifference curve through any given point gives you the points that are at the same utility level, all the points on the indifference curve, the points that are better than it, and the points that are worse than it. Now these numbers that we associate with the indifference curves, it's really important to remember that the numerical utilities are completely arbitrary. So what we're doing is just ordering the indifference curves. What really matters are the indifference curves and the shape of the indifference curves themselves. But the utility functions are useful tools. Right? What really matters are the preferences. And so the way we number them, as long as they are numbered in increasing order as you go to more preferred bundles, that's what's important.